Okay, be quiet because I'm talking. Okay, Manuel, here you go. This is a lesson for you. Now, you can tell I have lovely handwriting. So you can see that the top numbers over here, those are natural numbers. 1, 2, 3, 4, 5, up to infinity natural numbers. But if we add 0, then they become whole numbers, right? And that's the extra thing. We added a 0 to this set, see? Then we have the fundamental theorem of arithmetic that says every whole number, well, this is a set of whole numbers, can be written as the product of prime numbers uniquely. What are the set of prime numbers? 1, 2, 3, 5, 7, 11. Going forever and bopping around skipping is not uniform into what's coming next. You see what I'm saying? So what we got here is, how to find the primes. There's an example. So the examples are 8 can be written by the product of prime numbers 2 times 2 times 2. So I call 2 times 2 times 2 the DNA of 8, because that's the only way 8 can ever be written is with these 3 prime numbers. 9 is 3 times 3, and 10, as you can see, is 2 times 5. And 15 is 3 times 5, and 11 is prime, but it can be written, in fact, as factors of its own prime, 1 times 11, see? So 11 is prime. So let's go, for example, let's say, how to find the primes of 625. Okay, well, the way to do that is first find any prime number that divides into 625 without a remainder, see? So what we got to do is find the DNA of the number. In other words, the DNA is the product of prime numbers, the uniquely sequenced product of primes. So let's take a look over here. So if we know that 5 is a prime number, and you know it's going to go into 625 because it ends with 5. So that means you could take 5, divide that as 125, and then take 125, and here I got them stacked. You can see that 5 goes into 625, and 5 goes into 125, then 5 goes into 25, and 5. So the DNA of 625 is going to be equal to 5 times 5 times 5 times 5, which can be written as 5 to the 4th, but it really doesn't matter. So it's the product of primes. Okay, so why does that matter? Well, it matters because if you want to add fractions, you can look for a common denominator in the two different denominators. That's not always easy. So what I do is I just multiply the two denominators together because I know that'll always work, and that's the greatest common denominator. And then I use the fundamental theorem of algebra, which I'm just calling it over here FTA, another word for that, or if I use FTA, or I can use the word DNA, all of it means a unique number. So let's take a look. So here is how to find the lowest common denominator using fundamental theorem of arithmetic. You see that? Which I call the DNA of a whole number. Examples of DNA of or prime numbers products means multiplying primes. So let's take a look now and find what is the DNA of 1024, which is called a kilobyte in computer language. So it turns out 2 goes into there, 512, and 256, and 2 goes into that, and 222. If you find that, it's pretty interesting because 10 to the 24th is 2 times 2 times 2 raised to the 10th power. That is the unique prime factorization of 1024. So how do you use the fundamental theorem to find the least common denominator of fractions? So let's take an example of, you got 1/5 plus 1/3, that equals 8/15, see? And find the DNA of 8 and 15. So 8 can be written as 2 times 2 times 2. And since there are no common factors, 8/15 is the least common factor. Or you can say it's as simplified as it can get. Okay? So after that, then I go over to here and I say to myself, look, how do I add fractions without worrying about whether I have a common denominator or not? So the way I do it and the way I teach fractions, I don't normally try to get the least common denominator. First, what I use is this thing. You see that's monster face over here. You see that's a nose. So here's a nose again, but now I'm going to use it to add fractions. Notice that this bottom part is the first step, that's the second step, that's the third step. Even though that adding, it all means multiply. So we have to take the first step, which is b times d, and the second step is going to be a times d. You see, follow the arrow. And the third step is going to be b times c. That will always add every single fraction in the universe, although it may not be the most simplified form, but we can always find the most simplified form using the fundamental theorem of arithmetic. So there it is. The bottom of the nose is step 1, and the second move is step 2. Make sure it's in this order, and step 3. So I remind students that that makes a nose of a face. See, step 1, 2, and 3. So I call it the nose. I say the nose knows how to subtract and add all fractions in the universe. Example, 3/5 over plus 2/25. Now you could take 5 and say, oh, I can make a common denominator by multiplying 5 times 5 and then multiplying up here 5 times 3, right? I don't worry about it. I do my nose. What's 5 times 25? 125. Okay, second step, 25 times 3, 75. See that? And then 5 times 2, that's 10. So now when I add those up together, you can see that the top one ends up being 85 1/25. But there's a good chance that's not simplified to the most simplified it could be. So now we're going to use the fundamental theorem to simplify 85 25. Well, the DNA of 85 is 5 times 17, and that of 125 is 5 times 5 times 5. So we stack them up, you see. 85 can be written as 5 times 17 times 5 times 5 times 5, but this divides out, and so my most simplified form of 85 1/25 is 17 25. And so that tells us how. Now we can use that same nose, down here, for subtraction, you see. So here's the nose. Now step 1, step 2, step 3, but now instead of plus, I have minus. Doesn't matter. Follow the sequence. 3 is 125. 25 times 3 is 75, and 2 times 5 is 10. If you subtract that, that's 65 1/25. Then we look at the DNA, and we find out that 15 can be written as 65 can be written as 3 times 13, and 125 can be written as 5 times 5 times 5. Yeah, so you can see that one set of 5 will divide out, leaving 13 25ths, and that's the most simplified form. So that only leads us to 2 other things to be able to do all fractions in the universe. And first, it is called multiplying fractions. Again, multiplying fractions is pretty easy because I call it skiing. And I don't know if you can see this guy right here, but that's a guy skiing down a hill. He's got 2 poles, and he's got a hat on his head. And these are the 2 skis. And he's skiing across. So that means that what you do is that you go skiing. So that what you're going to do is just put them in there, put the multiply sign as a dot, 3 times 2, and that's it. Then use the DNA, and we see that 6 is 2 times 3, and 25, so there's nothing to simplify, so 6 over 125 is the most simplified form. The last thing is how to divide fractions. So first you must whip it, then you must flip it, then you go skiing, and that's the answer of all fractions in the universe. So what I'm saying is that you see that's A divided by B, or A over B divided by C over D, right? So you must whip it, but it's not, that pink thing is a whip, see it? This is a whip. And you only whip, life is not fair, you only whip the second guy always. So when you whip it, it's in pain, it goes, and it flips. So when it flips, you see, now you flip the fraction, now I apply the second fraction. So here, we started from here, right? It was A over B divided by here. I've already whipped the second guy, and he flipped, Not only does he flip, but everything disappears here except for the dot. That means now it turns into multiplication, yeah? So then, once it's flipped, right? It says it was flipped. The sign turns into multiplication, and so now the final things go skiing. So then I know that, well, in theory, if we go skiing, it's A times D over B times C. So over here, here's our problem. Here it's been whipped. Here it's been flipped. And all that's left is go skiing. Now 75 over 10. But How do we know that's the most simplified? Then we use the fundamental theorem of arithmetic, or the DNA of the number, of any whole number. And I know I can write 75 as 5 times 5 times 3, and this is 2 times 5. I know that 5 times 5, so the most simplified form is 15 over 2, which is 7.5. Okay, see if that answers your question.